So, hello everyone, we are group 9 and I'm Sumudhu Lakmali and my other two group members are Viraj Tanushka and Hamsi Sankar. So, can you go to next slide? So, we are doing digital signage based user targeted advertising. Next slide. So, as you can see in these pictures, digital signages are used in everywhere now. It is the best platform for doing advertising because they are attention grabbing displays. The other thing is they can be updated in real time. Because of this, in most places like railway stations, airports and bus stations, these digital signages are used to show the time schedules and messages to the passengers. The other thing, it is cost effective compared to the handmade boards. There is an initial cost to implement a digital signage, but the owner of digital signage can later use this digital signage to make money by promoting the brands and doing advertising. Next slide. So I said that digital signages are the best platform for doing advertising. But the problem is they play advertisements without targeting the users. They just play advertisements in the screens. They have no idea who is watching it. Because of that problem, most of the advertisements playing in the screens are not relevant for the people who are watching it. And the other thing, the technology is very inefficient. Most digital signages, what they are doing is they use a media box and a TV to display the advertisement. That is inefficient. The other thing is most Sri Lankan digital signage companies don't manufacture digital signages by themselves. What they do is they import and they sell. That's why the existing digital signages are so very, very expensive. Next slide. So as you can see, these are three main leading companies who is doing digital signages. You can see they are really expensive and none of these companies are doing user targeted advertising as well. So next slide. So we have our solution. In our solution, we are doing user targeted advertising. We identify what kind of user is in front of the screen and we display the most appropriate advertisement for that user. So our system mainly consists of three parts: user detecting and identify unit, digital signage controlling unit, and smart power supply unit. So next slide. So this is the business model. It costs us 40,000 rupees to produce one item. It includes both software, web and hardware cost. And we are going to sell our product at 80,000 rupees, keeping 40,000 rupees of unit profit. And we are going to get 5,000 rupees from each customer yearly to give our best of service and to maintain the system. Next slide. So this is the solution architecture. So the owner of digital signage can upload their advertisements using the web application or the mobile application we are providing them, and those advertisements are controlled by digital signage controlling unit, and the best advertisement will be displayed according to the user who is in front of the screen. So this to identify the user, detect the user, we are using user detecting and identify unit. And we also have a smart power supply unit. Actually, the user, the owner of the digital signage, can turn on and turn off the digital display using our web application. So the next slide. So here, the data and control flow. The advertisements are given into the system using the web application or the mobile application, and they are getting into the web server. And those advertisements will be given into the Raspberry Pi microcontroller. Then those advertisements will be saved in the SD card. In the other side, we have distance sensor and the camera module, which is placed with the digital screen. So this distance sensor will generate the data and given to the Raspberry Pi microcontroller. It will give the distance to the customer from the digital signage, and then microcontroller will generate a signal and give it into the camera module to check to get the image or not. And after getting the image, that image will be given into the microcontroller, and it will be processed, that image will be processed with the trained models and get the result of the age group and the gender of the person. And according to that two criteria, gender and the age group, the most appropriate advertisement will be selected and it is given into the output and displayed in the digital screen. The other thing is the smart power supply unit. The user will be given the power supply controlling signals through the web application or the mobile application, and it will be given into the microcontroller. And then the microcontroller will generate relay controlling signals and will be given into smart power supply unit. And then this unit will control the power of digital screen. So I invite Viraj to continue.
Okay, let's see why we use, what are the technologies we are using, right? We are using Raspberry Pi as our single board computer, and we use Python as our main programming language, and OpenCV as our OpenCV library as the face detection and analysis. And we use AWS as our web server, and Django will be our web application framework, and we will use Flutter and Dart for the mobile application development. And now shall we see why we choose these technologies. So first thing we consider was feature and performance. As you can see, this is Raspberry Pi 3 features, and as you can see, all those features are really relevant to our project, like CPU, even the GPU, since we are processing images, and RAM, the networking, since we are connecting these things to the web server. And of course, we need storage because we need to store the images, right? So micro SD and the ports like HDMI, very useful since we are connecting a digital screen. And if our advertisements contains audios, we need analog audio jacks, and of course Ethernet and the CSI, camera serial interface, for the face detection purposes. And of course, size and weight also important when we thinking about final product is going to market. So we have to consider those as well. Then shall we think about the when we talking about the Python, it interact well with multiple platforms, like we are using Raspberry, OpenCV, Django. So all together we can create a very consistent project. So even the OpenCV give features such as face detection and image processing, and Django is search engine optimized Python web framework, and AWS on the other hand offers number of economical and flexible services. Even the Flutter and Dart combination, we can use the same code base for both to develop both iOS and Android apps at once. So the next factor we thought about is the cost. Since we can get Raspberry Pi 3 boards from the lab, and already we have the $50 credit from AWS, and the rest of the technology is Python and OpenCV. Those are completely open source, so we can use them as well. And the next criteria, resources and community. All these technologies have excellent documentation with a huge resources, and the massive community involvement with a huge number of contributions, and it is a very supportive community. So even when we're doing this project, we might come up, we might encounter with some sort of problems, and we are pretty much sure that Stack Overflow, Quora, Reddit, those platforms, we can resolve our problem. And the next thing was actually security. All these technologies are continuously maintained, and bugs are fixed and they are updated. So these are the criteria we thought about. Hans will explain the next. Hans.
Here while we are using these technologies effectively, another aspect we need to consider is the security and safety measures of our products. So when we look at the web application perspective, since we are using the Django framework, it gives us a lot of services, and one of them is the user authentication system, which we need because we are using a user login system. And also another safety measure is that we can use the AWS web application firewalls so that the outsiders can't attack our websites. And and when we look at the hardware components perspective, the one main thing we might encounter is that the overheating problem of the controlling unit, because we'll be doing a lot of processing with images and storing the data. And to avoid that, we might have to take some precautions over that. And also, we are hoping to uh, install a manual reset switch, which will be useful for an unexpected delays happen when with the servers. We might not want our system to collapse. So, and another thing we have to consider is the privacy fact, because we are using some cameras for detecting users in a public places. So users might get confused with the system we are using. So actually what we are doing here is some anonymous face detection and analysis only. There will be no face recognition or IDing the person. So we hope to put up a notice with the with that also, so the users can get a clear view of what we are doing this. And when we look at the infrastructure of the solution architecture, the main hardware unit, we have three main hardware units, and one is the digital signage control unit, and the user detecting and identifying unit, and smart power supply unit. Next slide. And the controlling unit, it consists of the Raspberry Pi processor, and the SD card is for booting and data storage. Here we will be in the user uploads some content to the web application. Those will be automatically saved also in the SD card. So in case of an internet connection failure, the display will still continue to show the latest content in the SD card. So, and also when looking at the, we also will be putting up a cooling unit, which will avoid the overheating of the product. So we'll be using a heat sink and a fan for that. And some indicators will be there to power on off, and a reset switch for refreshing the unit in case of an emergency. And here in the user detecting and identifying unit, we'll be using a distance sensor. We decided to use ultrasonic sensor, which can detect a person who is standing still in front of a screen. And we will put up a range to detect the person and activate the camera module, so it will be more reliable. And the camera module we used, you'll be using the audio cam, which comes compatible with the camera serial interface of the Raspberry Pi, so that it will be operated using the GPU of the processing unit. Otherwise, if we use a webcam, we might have to use the USB port of the Raspberry Pi, and it will be controlled using the CPU. So since we are using the CPU for a lot of processing, it is better to use this to work with the camera module, work with the GPU. So that's why we decided to go with the audio cam, and some indicators will be there for the camera on off. Next slide. And the smart power supply unit will be implementing some relay modules for that unit. It will be the screen on off will be controlled by the Raspberry Pi, the power outlet, and the user can do it using the web application. The web application actually has a features like he can decide what time he wants the screen to be turned on. Maybe the time he's opening the shop, and he need to turn it off when he closes, like that. So it can be automatically operated using this relay modules using power supply unit. Next slide. And here is our bill of materials for building our product, and we are hoping to get some of the components from the inventory from the university, and with that we can build our prototype at around 10,000 LKR. And our demonstration plan is going to be setting up the control unit with the components, and we're gonna need an LCD monitor from the department to use as the display, and we might use some adapter from VGA to HDMI converter to connect it to our device, as it is compatible with HDMI. And in the process, we'll be logging to the web application and uploading some random advertisement, and then we'll be uploading some targeted advertisement for the users based on the age and group and gender. And then when the user comes in front, it will identify the person and show some relevant content by doing the facial analysis and the age. So our project timeline, we divided into 7 steps for the 15 weeks. And the first step, for the first 2 weeks, we'll be familiarizing ourselves with the frameworks, Raspberry Pi, and other stuff. And then in the next 2 weeks, we'll be doing our web application outline for the front end and preparing hardware components. In the next 3 weeks, we'll be doing the server configuring and web development and front end, back end, and all the coding. And as the fourth step, we'll be doing configuring the OpenCV and the hardware units for that. And the fifth step, there we'll build the smart power supply unit. And in the sixth step, we'll print the 3D, do the 3D printing for the components to give final touch for the product. And as the final step, we'll be doing the testing and debugging in the 14th and 15th week for the whole unit. And that's the end of our presentation. Please feel free to ask any questions.
Very good job. The question I had was what exactly was done in this user detection and identification, what data is recorded, how they are used. I think you answered those questions already towards the end of the presentation, that you are going to do face detection and no face images are stored, right?
Yes.
So yeah, those things need to be clarified, say, in the product documentation presentation. Once you have finalized the product, right? When you're marketing this, those things need to be very clear. So it was a very good presentation. The slides, I really liked. The slides were simple and attractive enough. And the presentation, the way you presented was very good. You were confident, and you know, I can that you were excited about the idea yourself, that you know what you're talking about. It was very evident. On certain slides, there were some text which were a little bit, you know, too small to read easily. So that was the only thing that I could nitpick on the slides. The introduction was very nice. The motivation was presented very clearly, and you had a very, you know, good amount of details. Not too much, not too less, but a good amount of technical details. And I like that you had considered things like, say, in the events of network failure, how the backup would work based on the data available on the local devices, things like that. And you explained the design choices very well, why certain, say, hardware or software design choices were done in certain ways. You gave the reasons for those. That is very nice. That's what I really like to see. Then at the very end, the timeline, perhaps you didn't you know, think a lot about it. Each and every step was separated into separate weeks or couples of weeks. There were no overlaps, which is like not really practical. It doesn't exactly happen that way. But I guess you didn't really think a lot about that, which is not a big problem at this stage. But yeah, something that appeared odd, because you never really, projects never really happen with, okay, I'm done in this stage, I'm never going to touch that again, right? So there are, especially things like testing. So, I think what you had at the end as testing was testing the final device for certain test parameters, but testing actually happens throughout the design process, right? So, which we will be talking about in detail in CO324 and in the project sessions as well. So we will be learning about those things. That is fine for the moment. Yeah, so a very good job. I really liked it. Thanks.